we're going to demo the PDP protocol on the Filecoin network. We're going to cover a bit about how it works. We're going to show an application that's running with PDP data storage and demonstrate the benefits of verifiability. And we're going to show the live retrieval capabilities of the Curio node backing PDP storage in order to make a fairly real-time web app. So what you're looking at here is the PDP Explorer. We have a way to check out the mainnet PDP network and all the data that's on it. Right now, it's pretty quiet because we just launched the network. The proof set that I want to talk about today is proof set 0. First, I'll talk about what a proof set is. So a proof set is a mapping between a client and a provider, and it's a data set which organizes the data of a client and a provider pair. So if I'm an SP storing for a client, I will put my data for that client in a proof set. It's a very flexible container. You can add to it, you can remove from it. And it organizes proving. So you get a proof per proof set every day on the default configuration. Some of that is configurable and can be switched around. Proof set 0 is backing the data for a web app that we're calling the PDP Zoo, which I'll show you in a little bit. But just to take a quick look at what we have. So inside of this proof set, we have a bunch of different routes. Each one of these CIDs corresponds to, in this case, a file, though it's very flexible and you can add whatever data you want beneath one of these routes. It could be an aggregate of many files, for example. The size is pretty much up to you as the provider and client, whatever you agree upon. So the proof set is kind of like the Filecoin co-rep sector in that it's the fundamental unit of storing data, but it has different properties which are in many ways nicer. For example, organizing lots of small files together. Okay, so that's the data in the proof set. The PDP Explorer maintains some information about the operations on the proof set, which we'll get to a little bit later, but you can see we're adding routes here. And somewhere earlier on, for example, we're removing routes so we removed routes. We removed one route as well. So the proof set is dynamic, and this Explorer helps us visualize the data, or at least see what data is in there at what hash. And the proof set is being proven. The point of PDP, which stands for proof of data possession, is that we're actually proving that we own this data, that we possess this data. And we have this nice heat map, which shows us which routes have been randomly chosen to be proven, and all of these have been proven at one time or another. By default, we get 5 proofs a day. Okay, so this is the data. Now let's show this application which is using it. So this is a very simple web app. We can take a look at the HTML later to see what it's doing. You provided a public API, an ETH API, to get to the Filecoin network. State, you provided a Curio node. This is where my Curio node is at. This is the node which is hosting the data, which we were just looking at. And then you provided a proof set ID, which is like the PDP network number for the data set. And then it makes a bunch of assumptions, which aren't generally true, but if you get to decide what's in your proof set and you only want to put images in there, then this will work. So what it does is going to go to the chain. Let me just take a look at the source. Yeah, actually, we'll pull it up here. So what it does is it goes to the chain over the API. It figures out from the state of the contract all of the CIDs that are in the proof set, just like the ones that we looked at inside of the PDP Explorer. It will get that CID data. And then what it does is it requests them from the Curio HTTP API, which is a public API. And then it displays, assuming that these data files underneath each route are images, it displays them under an image tag. So it's very simple. And we can watch that happen. We'll take a look at the network as we do it so we can see all the calls going. So we're going to Glyph to get a bunch of information about the contract. And then we're going to Curio on the HTTP API to retrieve the images. So you see that. We'll probably start to see some glyph node timeouts because we're just asking for too many information requests from the API. But more nice to look at is all the pictures of these lovely cats. And the premise of this demo is really that the entire point of information technology is to display cat pictures over the internet. So we're doing our job correctly. A few interesting locations of members of the FilZoo team. So they have very exotic pets. And there you have it. We're loading. You can see some live loading. And that's about it. Okay. So that's all well and good. But in order to demonstrate how to do things in a little bit more depth, what we're going to do is add a picture into the proof set and then show that we can display it through the Curio API. So what we're going to do is add the pink fairy armadillo, which is an amazing creature I've only recently learned about, into the proof set. So I've already put this over onto my box hosting my Curio node. If you go to the roots, we should see pink fairy armadillo JPEG. Cool. So what I'm going to do is add this to my SP proof set. So it should be said that in the current state of the PDP protocol, we don't have a decentralized deal making or client provider matching functionality. That's something that we're hoping to build quite soon as part of the FWS integration effort. For now, this works in the context of something like an on-ramp where there's a provider who knows what the client wants and they will go in and add it. So the Curio API I'm about to show you it's a management tool, something like the Lotus Miner CLI, if you're familiar with how we're approving, which we can use to modify the contents of our proof set. So to get started on that, there's really two steps involved. So this PDP tool talks to the Curio node, which by the way is running, so that's the database in case you were curious, because Curio works nicely on big SQL database. This is the Curio node, which doesn't like that people are calling it from different domain names, but that's okay. What we're going to do is upload that file. So upload file is a nice command which does some chunking over the file and adds it in a bunch of different upload steps. You can only upload 200 megabyte chunks over the Curio API. So it helps to have something which does automatic chunking. However, this file is really small, so it's not going to matter too much. I'll just modify an existing query I have running. We don't really care about the dry run. I also don't really care about getting a trace of the chunks because it should be really simple. This is the service URL. So this is the public domain name, which maps to the server's IP. This is the service name. So this is an authentication measure, which allows me to actually do this upload. So this API is protected. And what we're going to do is upload the pink fairy armadillo JPEG. Okay, let's see how this works. Cool. So it works. And now we have this fun CID. So this on the left side is the root of the CID, rather the root of the aggregate of a Merkle tree composed of all of the chunked CIDs. This is the synced chunk. So they're the same because there's only one chunk. The piece size, as you can see, is just 130 kilobytes. So we're not over the 200 megabyte limit by any means. So the second step now is to go PDP tool, add roots. So again, we're authenticating on the service name. We're also saying the proof set ID that we like to add to. And we're saying the URL that we're hitting the API on. And now I will modify this previous query to have the correct roots. So usually it helps to wait a little bit. I think we should be fine now, but just check the Curio node. Not seeing anything there. Let's see how this goes. Cool. Okay, so now this should be added to proof set ID 0. We could take a look at the PDP Explorer and refresh. We should be able to see a recent add routes command. Assuming everything is going right, it might take a little bit of time. You can go to Filefox and double check that things are working right. This would be our contract for the PDP verifier, is that? And we can see that there's a pending message here. We can check the PDP Zoo, which might be actually ahead of the Explorer, because it's going to be talking directly to the chain anyway. Let's see if we have any luck reloading the PDP Zoo. Yeah, great. Although our Explorer is taking some time to catch up, the Glyph API hits here have gone straight to the chain state, found this CID, which is identical to the one that we've just added. If we go back to the right window here, and then it went to the Curio API and fetched this. And so we've added to our proof set, which is kind of cool. Okay. I think there was one more thing I wanted to show you, which is that the verifiability is a nice feature of PDP. And so here in the zoo, we're linking to a verification step. No big new thing for you to see. This is just proof set 0. But the point being made is that we can go take a look and see that we've been proving on time. Here's a message which will link us back to Filefox, which shows that we proved on April 13th. So about 12 hours ago, we've proven possession of the data. And if we really care, we can start to really get into it. And we can even take the hex of the Merkle proofs, which have gone to different pieces of the data inside of our proof set, and validated that we have for sure some of the leads which were randomly selected. And so we have some nice probability of having everything in the proof set. So you can always do that. And you also get a nice visual of all of the things that have happened. So in closing, we've gone through, we've seen how to visualize the PDP network that's currently on mainnet, how to build an application that's using the data that's in PDP and links to verifiability of the data that's on there, and how this interacts with the chain itself, all being on mainnet, and then finally getting into how to operate a Curio node to actually back this up as part of being a storage provider for the PDP protocol on the Filecoin mainnet. So I'll leave it at that. Thanks.